In this video, we're going to talk about how to graph polar equations of conic sections. So let's start with this example. Let's say that r is 6 divided by 2 minus cosine theta. Sketch the graph and determine the eccentricity of it. Now, there's two forms you need to be familiar with. R can equal ed divided by 1 plus or minus e sine theta, or it can equal ed over 1 plus or minus e cosine theta. E is the eccentricity of the graph. Now, if e is between 0 and 1, then the conic section is an ellipse. If e is equal to 1, then we have a parabola. If e is greater than 1, then it's a hyperbola. Now, there's four variations that you need to be familiar with. So here's the first one. R equals ed divided by 1 plus e sine theta. The origin, also known as the pole, this is going to be the location of the focus. Now, for this particular graph, it's going to open towards the focus in a downward direction. And above it, you have the directrix. The distance between the directrix and the focus is known as d. And so that's the d in this equation. E is the eccentricity. And above it, you have the directrix. The origin, also known as the pole, this is going to be the location of the focus. Now, for this particular graph, it's going to open towards the focus in a downward direction. And above it, you have the directrix. The distance between the directrix and the focus is known as d. And so that's the d in this equation. E is the eccentricity. So in this case, we have a horizontal directrix above the pole. And the focus is the pole, which is the origin. Now the next one is r equals ed divided by 1 minus e sine theta. So once again, we're going to place the focus at the origin. But this time, the graph is going to open upward as opposed to downward. And the directrix is going to be below the pole. And we still have a horizontal directrix. And so you can say that the directrix is y equals negative d. It's d units below the focus. For the first one, it was y equals positive d. But for this one, it's negative d. Now the next two are these two equations. Ed divided by 1 plus e cosine theta. And the other one is ed over 1 minus e cosine theta. So if we have positive e cosine theta, it's going to open towards the left, with the focus being at the origin. By 1 plus e cosine theta. The focus. For the first one, it was y equals positive d. But for this one, it's negative d. Towards the left, with the focus being at the origin. So the directrix is vertical this time, and it's to the right of the pole. And the equation is going to be x equals d. For this one, the conic section will open towards the right. And the directrix will be x equals negative d. Now let's go back to this equation. R equals 6 over 2 minus cosine theta. So the first thing I want to do is identify which of those four equations I have. And so I'm going to have this one, ed over 1 minus e cosine theta. Now what I want to do is turn this number into a 1. So that's the first thing I'm going to do. To do that, I need to multiply the top
hello, huh? Praveen. Hello. Hello, hello. Okay, okay, I can hear too, but no one of the either the secretary or the coordinators, they have not come yet. Do you know what to do or what not to do? Do you know what to do? We joined SCS today. I think we have to. It's a reading group, so we have to read some books regarding the topic of semiconductor physics, and then we can discuss. I think that's the goal. I don't know, which I think that's the goal. Because the first day when I got to know, I joined many clubs. I left many of them. I think this is the only club I am presently in, except that other clubs I was having less interest. That's the thing. No, yeah, yeah, he gave one. No, have you read? I skimmed through the pages of the book, Neiman. Yeah, Neiman. Its book. The full name is. Let me. I have the PDF. I think it's by Don A. Neiman. You can get it on Zlib. You've heard about Zlib? No. Yeah, yeah. I found it there only. Semiconductor Physics and Devices. The book's name is. And the second chapter is of quantum mechanics. You think mainly many of things you might already be knowing. I think like we already know the uncertainty principle and the wave particle duality and other things. The new things which are there are basically Schrodinger's wave equation. Yeah, yeah means compared to if you have done JEE, the only new thing is there is calculating the potential well and the infinite potential well and electrons free space. These three to four things I didn't know, except that I knew everything. Wait a minute, let me share the screen. Should uh, okay. Can you see the screen? I mean the PDF. Yeah, yeah, here. See, like I think before this, you already know everything. I think uncertainty principle and other things. Yeah, no, you know this wave particle duality. You know, means these momentum equals stretch by lambda and all those things. Yeah, this experiment I didn't know, but you might know Davison J. Garmer. Yeah, I heard about it, but never knew it in this depth. It's not in depth. Basically, it has been explained, I think, in here only. So this much, I think you already know. Uh, from here, the things I knew the equation. I don't remember it, of course. I knew this form also, but after that, this potential well comes. Like till here, I knew. Did you know till here? Some of the things are some of the yeah, 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 yeah. It's what you call operator, Hermitian operator. Yeah. Yeah, yeah, the secret let me show you. You can see here this one. No, this is the same form. No, both forms are same. This is yeah, you know this form. No, here. No, no, no. Yeah, yeah. I know, I know. Yeah, E minus V1. E minus there's a term E minus V. It comes this side. This is one dimensional. This is one dimensional. No, no. This is not X Y Z one. You are confusing with the other one. I think there's a. Oh yeah, I get. No, yeah, this is also time dependent. I'm telling the no, there's an equation which is it is like it has differentiate in all three directions. This is x direction only. It is unidirectional. You can see that because the equation I learned during my J prep was means it was in all three dimensions. It has the I think don't remember some function differentiated partially differentiated through x, y, and z, and then it was equated to something. I don't remember the exact. I can understand that because I also learned in chemistry only. Yeah, we means J during the engineering profession, but I skimmed through this book. So basically, for above this, I knew everything. Here also, wave equation, I knew many things. I don't didn't know about this time dependent portion. This about this eta means separation constant. I think you also don't know about this. Yeah, I also, but I read this, so but I didn't understand that much. But still, it was quite good to know because see, yeah, this is this term. This term is here. I'm let me show you. This term is here. Yeah. Yeah. Yeah, this can told be it's not exactly the same. It has been divided by um here it has not been divided, I think so. Yeah, here it has not been, and this is 5 1. This is a different one because it is only about angle here. J. I think I know what is the J. I forgot. It was yeah, J is the imagine it is I. It's iota. It's iota. J is iota. Here it I actually here they have imagined it as e to the powers they have done. I think after that I could have when I skimmed through I saw yeah. See, I was telling no. They took phi and the radial function and the angular function as the powers of e here. You know about means actually vectors can be sorry quantum I'm saying complex numbers can be used to express vectors. Yeah, yeah, in two dimension, yeah. In yeah means yeah, so they use this only, but this is a basically a unit vector. It's very easy to say. You can consider it as a unit vector. I consider it like that only. Yeah. Yeah. So actually, and I, when you were asking J, I might know what it is. Actually, you can see between the first two terms and the third term and the other term, there's a phase difference. How is the phase difference? Because here is J is multiplied. No, so J is I. Iota changes the phase by 90 degrees. I pi by two. Yeah, so it is a very great thing to notice. I noticed it when after that they've explained too. But basic thing is the this function means the time dependent function. This is also time dependent, but when you expand it in terms of angle, when you take out the angular part, this is the angular part here, and this is the whole angular part. So you can see the angular part is dependent upon the time function. Means it is mainly dependent on the time function because see this phi one, I think it is the angular part as far as I think this one, and, and this is the radial, I think. So this is basic. This side is totally dependent upon the time and means so that I means I consider like I'm not sure, but I don't know that much. But so. But I think the time dependent part I got from this I got the notion that the time dependent part is a phase is a phase behind is a phase behind. I think yeah it's a phase behind the wave function the wave part. And and when I noticed this equation, it looked a lot like SHM, but I'm not sure it's wrong. I think it's wrong, but because it has this phi at the bottom too. So I thought, but I'm not sure. I mean, let seniors come; they would explain better. That's the thing. Yeah. Yeah. After this, no, he told us to read this chapter. So I didn't understand. Obviously, I didn't understand in much, but I skimmed through the pages and I was seeing what was written there. So means it's not that very out of means you can if you give a little time you might be able to understand these all. See here, yeah, I remember this. See the boundary conditions. This you might have also learned, I think. Yeah, yeah, yeah. Means the radial function should always be finite and single value and continuous. And yeah, these are conditions, basically conditions. Yeah, I've heard about it. After that, these all things means I didn't know many of. This is easy. This is very easy. You, it's basically they have derived the uh, wave number. You know what is h dash? You know what is h dash? No. Yeah, h by 2 pi. Yeah, I read this from I got to know by Feynman. It's basically what it has a special name means Planck's constant. No, no, Planck's constant is reduced Planck's constant. I, it has a name in front of it. I remember. So yeah, means this one is very easy. This part I found very easy. Means you can basically take out the exponential parts like this. You can see a by b. So you can find k means it's like calculating what you call it, it's a superposition of two superposition. What was it called? Yeah, superposition of two SHMs. It's like that. Yeah, yeah. Means yeah, it's by the generation. So I found it means it was not that difficult. I feel, and basically it was easy. So after that I don't. After I didn't read much because when you go down, there are some things which I don't understand even a little. Like this was easy. Physical meaning was all easy. We have learned these all things in class, yeah, class 11th and 12th. These are very easy. This one was a little tricky. I feel this function you might be knowing. You are saying this one, no? Yeah, this one has. Oh, yeah, I'm not sure. Actually, yeah, actually, I don't know. Yeah, Yale. I know. I know. MIT also Yale also. Yeah. Yep. Yeah. I've seen his lectures. It's on YouTube there. Yeah, I know. His no. Actually, I have watched the lectures of Walter Nguyen 8.03. Have you heard about those? Yeah. I was doing a course. I've recently started doing. I mean, what was it? Quantum computing recently, because we have a course. I think you might. Yeah. Did you register? Yeah. So that's in that there's a lot of use of quantum. So basically, in quantum computing, there's a qubits and they use superposition and I mean, what is the other term? Entanglement. So we not we need to know a little quantum physics. So I was starting. I have done 803, but didn't understand it when I did it in class 11. So, but now I'm trying to do it again. This one also is very easy. I'm saying. Yeah. No. Yeah. Yeah. I'll surely watch. I'll surely watch. I think it's the second or the third course of his series. Yeah, he did three courses, I think, because I remember starting the first one of Ramashankar Murthy, Ramakrishna Murthy. Yeah, oh, I don't remember the first. Yeah, very simple. Yeah, same with 1801, the Walton one. So basically, yeah, but the thing the lectures which you saw, I think the Yamashankar they were 2013, I feel. Yeah, so actually there are in MIT, I know about MIT, I don't know about Yale, but there are some specializations like you could go more into the certain field, that field. So actually they are given some academic, like we have academic mentors, no, they have also teaching assistants, like us only T. Yeah, TAs. They also, we also have, but their TAs are different. That is, yeah. Yeah. In that station, sometimes it's a specific topic station, so they teach too. As far as I know, I don't know sure for sure, but I think that is. So these all things means after, yeah, from here my mind boggles out. This is that potential only. You might be knowing. You know from till here it is known, and here this is also good. Till here you can also see means what are the values of this means wave number. So it has been taken as like this. So here I don't know what was D. D was here. D is no, here's A. Sorry, it's A. It's A. Sorry, it's A. A is I think A is the uh, at x equals to A naught. We have phi equals to it as means it's at A naught. I think what. See, here it is. Yeah, radius. No. Yeah, because here you can see there are three regions, and it's an so. But the thing is, I'm saying this is written of infinite. So, oh, I understand now. Correct me if I'm wrong. This is the region between where the potential is zero, and except that everywhere the potential is infinity. So basically, if anything is here, it needs to go here. Means anything is outside the this range, it can't. It's called quantum noise. I think. Means I don't. Yeah, tunneling, electron tunneling. Yeah, quantum tunneling, quantum tunneling. Yeah, that happens. Yeah, I've heard about that. Quantum tunneling you can also experience by a glass of water and your hand. You know that, no? No, actually, I saw a video on YouTube. I don't remember from which YouTube channel, but it was that if you press your hands too hard on the glass, you can see your finger impressions from inside the glass if the water is full. So actually, that is little bit due to quantum tunneling. As far as I means not of steel glass, I'm talking about glass. It's made of glass. So that's also due to quantum link. I think it's Veritasium. You have heard about the channel? No, it's very famous. Yeah, I have almost watched all of his videos. So I think he okay. Oh no, I found out the video. I was just searching. It's from uh, the Atomic Lab. I forgot. I remember the name. Action Lab. Action Lab. Have you heard about that? It's also a great channel. The Action Lab. The channel is. So you can basically search quantum tunneling at Action Lab, and there's a video of about 10 minutes how to make quantum tunnel in real life. It's a video. It's a 2-year old video. Yeah. No, they show this graph only. I mean, I don't think because I no, they don't show. This is the potential barrier. Yeah. Okay. So here is tunneling. You were talking about tunneling. It's there. My mouse is where was it? Well, let me close them. I need to close no, but still okay. You try then I'll try. Both can be on them. Why is anyone else not coming? Oh, I can see now. Yeah. Yeah. Mm. So it has here. Okay. You're showing this from which book? Yeah, I've heard of this book. Actually, I think this. Yeah, it's in. Yeah, I remember this is a book of chemistry. I was thinking because heard about this name. Yeah, I read Atkins for the physical chemistry. Yeah, it's a very complex book in chemistry. It's basically for wave functions. Yeah, I'm just thinking. Yeah, we are not even the what you call Sekis or Codis, and we are discussing, but the other people have not come. So that's the 2 to 3. They are there. Siddharth Gagan, Roy Shivakumar, and online too. What? Yeah, yeah, I see. I can see it. Means, yeah, yeah, yeah. I think we have. I think I've seen something like this in that book too. So as they are, these are the graphs of potential because I can see phi there. So phi is basically it's angular. No. Okay, okay. So I'm getting, yeah. Oh, oh, because I'm asking because it's phi is here. So what means in this book? What is the wave function it has been denoted? Capital phi or small phi? Angular. Okay, okay. What's what's the other symbol? There's a symbol. No, yeah, I can get confused. This is psi. Psi. Yeah, psi is angular. No. Okay, mentioned. No, so I'm asking that. So in this book, psi is for the wave function. Okay. No, yeah, like the book which I was showing here, psi is not the wave function. I think capital phi here is the wave function. Yeah. Let me show you. Yeah. I'm getting confused. Wait a minute. Let me check what is. Oh no, no, psi is the wave function. I was getting confused between psi and phi. Yeah, wave function. Yeah, it's the Yeah, 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 yeah. So in this book, yeah, capital psi is the I mean the total wave function. The small psi is then angular is a radial and yeah. Oh, in because okay, I get it. Yeah, I get it. Yeah, because I get it. I think is it related to the Heisenberg principle, uh, uncertainty principle? Because okay, okay, get it. The C1 is of the first excited state wave function, no? The C is the third one. Yeah, it's the first exercise. Yeah. Okay, I get it. Yeah, yeah. Yeah, mod square. Yeah, it's only proportional to the mod square. Yeah, I get it. No, so basically the thing which is a little weird is that it is not zero exactly. Means near the boundary it should be. But the thing is, yeah, but the thing is, like in quantum everything depends upon probabilities. So that's why it should not be zero. I think. Okay, it's so, it's a node. Okay, okay, I get it now. Fusion. Yeah. So here I in this book I was telling fusion has been disconnected. I feel. Yeah, in this book. So here I was telling about. See here I was telling that the capital psi is wave function. Yeah, the radial is small psi and the angular is phi. So fusion is here in the meet. Fusion, we can't hear you if you're muted.
Yeah, so
Y20. He
I'm
was
from
Y20.
Y20 actually.
You
Yeah.
didn't meet him on the Bulla session. Yeah, he
हाँ,
showed us the campus also.
आप आप कौन से उससे हैं? this thing. अच्छा,
I am Y20 at 21.
कौन
Yes.
मानस पांडे 21 का है?
हाँ, अरे मैथ नहीं था आपके उसमें बस हर सब हर मीट में था.
अच्छा, that Nishant's meet.
No, both meets. Bulla one also 7R1 in the morning when he
अरे,
showed us the
one was
280.
Nishan and one was I went to OAT and showed you the.
Yeah, yeah, I was there on in both.
अच्छा, you were there on both. Okay, okay.
Really?
Yeah, I am in campus. नहीं, I met Dio. ईशान Dio की बात चल रही है ना?
Shanti was a senior.
He's Y18. Like I met him
Yeah.
a couple of days back.
So yeah, I met him on the hall only.
Again, what were you asking? Like, yeah, yeah. So hall 3, like I'm in hall 3, and it's like super chill. You can go out, come back anywhere, and even other hall people can come into hall 3. Yeah.
Also his friend.
Only you hall. No, no, no. Only like what I guess hall 12 has some restrictions, and hall 13 is pretty much restricted. Like, so it
Sujan, so
depends like from which hall, how many cases came and stuff like that.
okay, okay. We get it.
Yeah.
So Sujan,
So
you
yeah,
know,
I would like to ask a small doubt about this wave function thing.
yeah,
It's probably not related to semiconductors or anything, but like wave function, we say psi of x. So what is it? Is it a vector or is it
yeah.
like something else, mathematically speaking?
Basically, as per this book here, it has been used as a a complex number here. It's a number basically. So
Okay. Yeah.
and t also
Okay.
because here time has also been.
That depends if you are going to
It's a
time
function
dependent
by the
Schrodinger or
name you
time
can say it's a
independent
function. So
Schrodinger. So if
right?
it's a function, then like how come we are using operators which we actually studied in linear algebra?
Because it might be treated as a matrix. I feel or something.
So yeah, one is I guess this Schrodinger thing, and the other one is Heisenberg. If I yeah, matrix formulation. Yeah.
Yeah, I've seen that matrix one. That was I was getting confused. So basically, this one I think it's a number. The Schrodinger one, I think. It's,
Uh,
no, yeah, tensor of some kind. We are not that
Like
comfortable with
tensor,
quantum.
I don't think it would be a tensor.
No, means some kind
होगा
of
तो vector ही होगा like. Yeah, and then you use operators to get this eigenvectors and eigenvalues of
yeah.
type vector. Yeah, the column thing. Yeah. But then I went to these advanced texts and they start calling it as state functions or not exactly function, the position states, momentum states, stuff like that. So I got pretty confused कि हो क्या रहा है मतलब.
States means
No, like
yeah. Basically, by state you means that uh, things which you measure when you get to know. It's like that. States when
huh,
they enter,
yes,
they
yes.
usually they consider measuring only.
So yeah. So like what I was going through this. The exact source is Barton Zwieback's notes of 805, I guess. So उसमें he writes in one of his notes, he writes that the wave function psi of x can be written as a superposition, arbitrary superposition of the position states, across all x's.
Do you remember
Uh,
the lecture name, lecture number?
the lecture number, yeah, yeah,
Because I
he
can.
writes it as a,
So
which
it
makes
was
sense, right? It is. uh, Linear differential equation, yes. Uh-huh. But then I'm asking
yeah. See,
mathematically
oh, no,
उसका
it's
nature
a
क्या
note.
होगा जो
Reading out this
solution.
one. No, it's 805.
Yeah, it's 8 to
Hello.
5. I guess
This
after दिस चेक डिरैक्स ब्रांड किट उसके लेक्चर में था, नोट्स में भी उसी में होगा शायद.
Dirac's Branchet notation. Yeah, I found it.
हाँ, डिरैक्स ब्रांड किट.
So here it has been away. Yeah.
No, there's some subtle difference in when you start using this non-denumerable spaces. Like you cannot write the vector in terms
Yeah,
of
I also don't know that much about
yeah.
species.
उसमें उसमें कुछ फर्क आता है, like there's a small subtlety of this bracket, and that's why people emphasize in bracket.
So
Otherwise, everyone would be
where
using
it
the
is about? I
conventional
mean,
vector
where it
notation.
is about the equations.
Yeah, just a sec. I'll tell you the timestamp. Okay, a second.
Because it has the Hermitian and unitary operators are in on page number 9. About is it
On
near?
note, uh-huh.
This is I think I don't remember the year. It's
It's
2013 one.
2013. Yeah,
Yeah.
2013. So yeah, check this 30 minutes 32 seconds of the lecture. और उसका notes में
Lecture number.
lecture number 9, Dirac's Branchet notation.
Yeah, lecture number 9. Yeah, this is that lecture. Yeah.
Yeah, so 30 minutes 32 seconds.
Yeah, here it doesn't mention the numbers.
Lecture video.
Lecture 9.
Yeah, lecture.
The
30
following
minutes.
content is provided under a
30
Creative Commons
30 minutes
license.
32
Your support
seconds,
will
I
help
guess.
MIT
Yeah.
OpenCourseWare continue to offer high quality.
Confuse. X. Stay.
Yeah,
We have
I finished this Alan Adams
here.
thing.
Well, we've talked about
वो मैंने
wave
first time में
functions
कर
and
दिया
we
था.
give the value.
Oh, I finished 803, but I have not gone through 804, 805. So I'm not that good in quantum that.
803 क्या है वो quantum mechanics है ही नहीं उसमें. 804 से शुरू हो रहा है quantum.
Wait a minute, I don't remember that one.
वो अरे यार वो साला वैसे भी 103 में आता है.
वो मैं I
और
studied
बल्कि
earlier in
हमें
class
हमें ज्यादा
12.
पढ़ाते हैं साला उससे।
मालूम है वो तो मालूम है. नहीं 803 is vibration waves, yeah. Which was no, I did the quantum mechanics from another physical another channel.
different places.
Oh, okay,
We're
okay.
gonna position.
Where was it? 20,
Now,
30?
what is the
Thirty
meaning
Can
of
you hear the audio?
minutes.
Can you hear the audio?
these positions? Nicole?
Sorry?
Means it depends upon the type of lecture. Like like some lectures of maths and physics I watch at 1.25 and 1.5 sometimes. But MIT ones I usually watch at 1.
MIT once I like watch it at one and I read the notes. साला मैं
Yeah, notes are good.
मैं
Great.
कानपुर का वो करता साला कहीं और होता मैं.
So, okay.
Now, here is how you can go wrong with this thing. If you stop thinking,
Yeah, here it is telling about the denumerables ones.
Denumerable ones and very
Yeah, here.
yeah denumerable basis. Yeah, so you cannot like write the basis as a finite number or an integer sequence. Yeah, because in Hilbert space you have this complex variables with inner product and
Yeah, Hilbert space is the
yeah,
David Hilbert. The David Hilbert
David
method.
Hilbert has this space because all the
Yeah.
wave functions they actually live in Hilbert space. Like that's
Yeah,
the
yeah.
Katz notation.
Because yeah, I've also heard that term many a times, and I know about David Hilbert. He was a great mathematician, but I don't know about Hilbert spaces much.
Okay, so yeah, from what I know very very little. Like it's just the name, just the definition and shit. But yeah, I'll just tell what I know. So uh, it's, so what the Hilbert space actually does is second यार कहीं underline लिख दिया था मैंने. Yeah, so the definition which he wrote in his note is a complex vector space with inner product is a Hilbert space if it is finite dimensional. So what if it is finite dimensional? And if you're yeah, if it is finite dimensional and a vector space with a complex vector space with inner product defined on it, like the basis vectors are finite. Yep.
Right. Okay, good.
Yeah. So the mathematical definition is should have a complex vector space and you should have inner product defined on it, and it should be a finite dimensional space. Like yeah. So what is it?
Generally, yeah.
Generalization of dot product. Yes, you can define it whatever way you want, but it should satisfy those given axioms. Yeah. So, but in quantum mechanics, we usually deal with infinite dimensional spaces, and there you have this extra completeness requirement. Uh, that is essentially which is this thing. Cauchy sequences must converge in this space. Yeah. This one is derived from that analysis part. There was a similar definition. Yeah. Bounded one. Yep. So because then your space becomes a closed space in topological terms, I guess. Yeah. So no, it doesn't say much about compactness, but it talks about completeness requirement. Like this Cauchy requirement is known as completeness requirement. अब मैं मतलब उतना analysis किया नहीं है तो exactly. Yeah. Yeah. So I have like very very do you say generalized idea. So I did a small project on topology in schematics. उसमें थोड़ा सा पढ़ा था. Well, what it means is that in a given topological space, if your any topological space is nothing, you take a set, any set, like finite or infinite, any set, you take arbitrary set, and you take a collection of its subset, like you define subsets of it. Okay, you take a collection of subsets such that the union of any two subsets must lie within your collection, and any finite intersection of your subsets must also lie within the within your collection. Then this collection of subsets is known as topology, and your original set along with this topology together is known as topological space. Like that is the abstract definition of topology, the one which mathematicians use it. No operators, nothing. So topological space.
When I heard about topology, I heard it usually in relations, like this
Yeah.
compares
So
that
उसमें
we are.
उसमें ये इसलिए हम ऐसे define करते हैं because it is the bare minimum structure required to define continuity. So like in mathematically, at least some guy proved it. Like कि आप इससे generalize नहीं कर सकते और to preserve continuity.
Okay.
But so उसमें मतलब ये क्या करता है कि metric space जो है अपना real line हो गया, Euclidean space हो गया. This topological definition generalizes all its property to like for a general space, and those spaces are topological space. Yeah, so you do not need a metric per se to define continuity in a topological context. So abhi मैं I'm
Yeah.
doing the course right now. I have taken this MTH 304.
Oh.
So yeah, compactness का मतलब है जैसे whatever this thing you take, there's something known as a cover, which means you're taking a closed set over your topological space. If all the elements lie within it and are bounded, then the space is known as compact space, compact
Yeah,
topological space.
I heard about it closed and bound because I think I've seen some lectures, random lectures on topology. So there
Yeah.
they talked a lot about this compact sense. Means it was like some things are bounded and they don't the objects are not outside.
Yeah, so your limit points must lie within the boundary of your set.
It's a closed set.
So it's a closed set in your normal sense, but then in topology that closed का definition थोड़ा generalize हो जाता है. हाँ अभी मतलब उतना मुझे like clear idea नहीं है because I did a very small thing on it. Yeah, I guess सीखना है अभी काफी. That's one way to define, and the other way to define is you take a sequence, the same Cauchy condition, that is. So you take a sequence, and the limit point of that sequence or any random sequence of the points within your topological space must lie within the space.
So basically, I'm getting from this that we do the proof of every bounded sequence. Means every bounded sequence has a Cauchy sequence in it, and means what was it? The proof?
हाँ
It's a
हाँ
proof like that.
उसका था वो. Yeah, that's this 101 में था वो.
Yeah. So the basically what you're telling about is it's something like analogous to this in
Analogs to
close.
this, yes. It's a basically in some sense it's a generalized version of that.
Okay.
Which converges to this thing, but it lies outside your set. Yeah. Irrationals are not compact, I guess.
But because
शायद.
it-
The
no,
rationals
both
are not. If rationals are not compact, then irrationals
then
also
irrationals
wouldn't
are
be.
not count. Yeah, I was saying.
the property is symmetric. Yeah. Yeah, yeah.
So-
you can define that root two thing.
So
Some sequence
yeah,
would converge to root
I was
two.
going through Google and I was searching what this compact sets spaces.
Yeah.
So here it is written a set S belongs to a set is called compact if every sequence in S has a subsequence that converges to a point in S.
Yeah. So that is
More general definition.
that the I guess the metric space thing. हाँ
Yeah.
वो भी है मतलब यार maths definitions are क्या बोलूं redundant हो जाते हैं कई बार.
Sometimes it's very difficult to understand. Means sometimes they say the same thing, but they mean in a very
Different
manner.
things. Yeah.
Yeah. Like here, from this definition, we can also say it's like a sequence which is bounded, but its limit is basically in, but it has limit also um, in the means
In
the
the yes the yeah.
okay. So this was discussion was on semiconductors, no?
हाँ but वो साला ऐसे ऐसे चला गया discussion.
वही देवादित्य तो आए भी नहीं.
अच्छा हाँ देवादित्य है ना इस ग्रुप का वो.
हाँ, आपको क्या लगा? और भी बहुत सारे लोग
अरे
हैं. 70 लोग
हाँ?
ऑफलाइन है. 17 people ऑफलाइन.
17 people are offline.
means
उसमें आधे से ज्यादा साले techies हैं.
वही तो आप सेकी में तो आप ही अभी और कुछ लड़के
मैं
ऑनलाइन
techie
भी.
हूँ मैं techie हूँ.
हाँ
हाँ?
मालूम है. ग्रीन होता है सेकी का नॉर्मली.
मैं क्या क्या बोल रहा हूँ?
सेकी में तो एक आप ही है मतलब.
techie काफी हैं यार 11 के आसपास हैं techies.
लेकिन एक्टिव कोई ऑनलाइन कोई नहीं मतलब
Active
इनविजिबल होंगे
कम है.
ज्यादातर. Secretaries?
Secretary secretary of the club, like it's a PR sort of thing. But there's a small catch. SCH is not a registered club, so हाँ कुछ नहीं मिलेगा. SCH is not a registered club.
वो it's not a
अरे
hobby group, no.
ओरिएंटेशन वगैरह करते हैं बट पर से ऑफिशियली रजिस्टर्ड नहीं है.
But it's a hobby group.
इट्स अ
There are hobby groups, no.
या नो टिल नाउ तो कुछ नहीं है और कमरा भी नहीं है यार. वो सबसे दुख लगा मेरे को.
वो
और रिसर्च प्रोजेक्ट विद फंडिंग. अरे प्रॉफ के पास साला पैसा नहीं है, हमें कहाँ से देंगे?
कौन है prof? Who is the prof?
अरे मतलब इन जनरल आई एम टॉकिंग लाइक
Oh.
रिसर्च में वैसे ही फंडिंग नहीं मिलती है. ओ हाँ वो हट गया.
Send them to IIT. So I have a doubt in this what you call quantum physics means basically what what was the name? Praveen was saying about this. Have you know about this potential well? So yeah. Yeah, so we were discussing means the weird thing is that the potential doesn't go to zero near the boundaries.
The potential I guess shoots to infinity, right?
The potential, the wave function, I think.
हाँ वे फंक्शन मीन कर रहा है.
Oh, so I got the wrong foot. So yeah, so but I was thinking that why it is necessary to go zero.
Because yeah I think I can answer that. I guess at least I'll try. Because I actually thought about it back then. So yeah, let me try it. So what happens is when your potential is actually infinite,
Yeah.
in order to for the particle to leak out of it, like leak is the term they
Yeah,
use in quantum
I
mechanics.
understand that means I understand means so according to the wave function has some non zero value at
हाँ
other places outside the boundary too. Yeah. So
नहीं नहीं नहीं
why?
नहीं नहीं in infinite wave in infinite potential well बाहर zero होगा well के बाहर
No, no, it's not zero. That's yeah. Can you show the? I mean, yeah, yeah, yeah. That's why
infinite
I
के
was getting.
बाहर
Yeah, here.
wait yeah second
Yeah, yeah. I was getting
हाँ
confused
हाँ
in that only because I understand
ये
at the boundary.
this is finite wait this is finite this v naught in a rectangular well I was talking about infinite well like v
I
naught
was just
tend to
talking about.
infinity
I was just talking about infinite well. You showed the finite one. No,
तो इसमें देखिए ना सब जीरो में कट हो जाएगा आपका
this is the
infinite में
infinite one. Yeah, that's why that I
yeah
got confused from the between both the wells. So Praveen,
because when you actually write the yeah
yeah, yeah, that's why I was getting confused because Praveen showed me this diagram and he told me infinite well.
अच्छा
So that's why I was getting
okay
confused. How can it be get some value outside it?
हाँ नहीं outside because it would require infinite of energy to actually cross well
Yeah. I get it now. So this is basically
but
of a finite well. So yeah, now it makes sense.
yeah over this but then because of
Um,
this wave functions nature yeah effectively yeah but then again the catch is you cannot define kinetic energy precisely because you cannot specify the velocity
velocity yeah.
that's the catch there
So actually, in a way, this I asked Praveen too. This pertains to the Heisenberg's principle. Yeah.
yeah
This
so in
this
some sense I guess you can connect but I have no exact idea of how to do that
yeah, because I was basically thinking that this space is means the why it is not zero at the boundaries due to that uncertainty only.
हाँ uh, is but then the
Yeah, but
mathematical statement I guess there's this I h cross term there uh,
yeah, H cross means the
the
reduced reduced.
हाँ I h cross वो assumption लेते हैं शायद उसमें
Yeah, here in this
because
book book also I think a J has been used for I. I is iota. No, you're telling no.
I is iota
Yeah,
I h cross something
it's
yeah
here. It's in my book that
I
in Neiman it's J.
like a commutator of x cap comma p cap is I h cross and this happens for every Heisenberg pair of variables like
Yeah,
energy time
also
and stuff like that conjugate variable yeah uh-huh. Energy and time also you cannot observe with infinite precision yeah. There was these things with angular momentums yeah spin
yeah,
angular momentum
yeah, spin
and
and
नहीं एक सेकेंड आप
no
एंगुलर
spin का नहीं
मोमेंटम
होता.
और स्पिन
Spin,
को साथ में कर सकते हैं बट LX एंड LY SX और SY ये नहीं
no,
कर
I
सकते
yeah you because
हाँ
it's upon the components. Yeah,
it's
you can
about the
calculate
components
one.
like the orthogonal axis वाला part
Yeah, so I see. Actually, I doubt because here it is the infinite potential well. You can see my screen. No,
एक सेकेंड यार
it's the other stream.
थोड़ा डिस्कॉर्ड चूतिया सा है
So you can click on the other
ओ
stream, right?
माइनस फंड है
Yeah,
माइनस
yeah. So in this, here it is the infinite well. So here
हम्म
the graph is not given. I think it's Niemann.
हम्म
Graph is not given, but here it should be zero.
कहाँ पे
Mm.
तो जीरो तो कर रहे हो at x equals to 0 and at x equal to a
Yeah,
because
at x
of
equals
the
to n and zero,
infiniteness
the the potential is zero and the wave function should also be zero because it's an
wave
infinite
function
potential.
है हाँ
But so there's no probability of an electron being anywhere outside or means even
outside of this So
Yeah.
one way to derive it is that you use the constraint equations for a finite potential well and then put V naught tending to infinity.
Yeah, here they use the boundary condition to
हाँ
give
तो
that.
ये डायरेक्टली लिखा है ना इसने बट
Uh,
वी हैव टू गिव अ फिजिकल आर्गुमेंट कि आप बाउंड्री कंडीशन क्यों लगा रहे हैं.
okay, I get it now. So here is one more thing. Yeah, this is the thing we were talking about, I think. Yeah, here are the diagrams. I didn't read
So
here till now.
this infinite नहीं हाँ
It's
in
infinite.
infinite
It's
yeah,
infinite. It is
Yep.
infinite potential well. Yeah, so here the J has been used. Yeah,
Oh, with
yeah. Here the notes.
yes.
These points. I
हाँ
mean,
in at the notes yes I guess हाँ. अरे कलर
these
बदल
points.
जाए कुछ
This point.
ब्लैक ब्लैक लगा दे हाँ.
Nice point.
Yeah. Classically, you can observe a particle anywhere, like same probability, I guess. Yeah.
Yeah, this was also my also doubt was there because I in this diagram now I have another doubt. This graph is not symmetric or something, no? I think this is a problem in the
अरे
textbook.
नहीं नहीं वो डायग्राम उल्टा सीधा बनाया उसने बट सिमेट्रिक
Yeah,
होना
because
चाहिए.
here it is not. It is here it is symmetric and here it's not.
हाँ 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 तो नहीं
Yeah,
वो डायग्राम उसने प्रिंटिंग कुछ
textbook
उल्टा
की
सा लिख दिया.
textbook गलती है. So here this is the potential
अरे
point.
भाई स्टेप पोटेंशियल साला डर लगता है मेरे को इससे.
Why means what?
हाँ यस Euler's theorem. This is with the symmetry thing, right? Yeah, every conservation law has the symmetry associated in with it. Yeah.
I've heard about
Like
that.
I know just from the pop science and from YouTube videos. So
Yeah, I also know from
उसने
that.
वैसे नहीं किया यार.
Yeah,
Yeah, we can do that. हाँ हाँ हाँ. Yes. हाँ.
yeah. This,
हम्म. हाँ. और वैसे मतलब मेरा पर्सनल ओपिनियन ये बड़ा चूतिया सा आर्गुमेंट लग रहा है
yeah,
लाइक
yeah. This is
हाँ हाँ हाँ.
which book? Which
नहीं
book are
नहीं
you
नहीं
talking about?
it is the argument. I know it is the argument. I like saw a similar argument like this. Even Fermat's theorem का argument भी ऐसे ही रहता है कुछ.
Format theorem is another level.
अरे वो लाइट स्ट्रेट पाथ वाला ना इधर जा सकता है ना
Now
उधर
there
जा
is
सकता है. Like
yeah,
it
and
shouldn't choose basically.
no, in the least
Yeah.
actually
Yeah. That sort of happens in quantum mechanics. But then what I read in some article is that when you actually formulate this in terms of Feynman path integral,
yeah.
uh,
So
yeah,
Feynman
I
path
don't know.
integral
वो QFT का part है. Like it comes in QFT.
in QED I
तो
think it comes in QED.
अरे वही यार क्वांटम फील्ड थ्योरीज का सब डिविजन्स हैं वो.
Okay.
वो मैं सब मिला के QED QCD ये सब QFT में इंक्लूड करता हूँ मैं.
Okay.
So उसमें you can write the thing in terms of your classical मतलब analogous to your classical
Because
least action principle.
now my doubt here is with Praveen's statements with this book because we are talking about classical mechanics here. No.
symmetry between the sides of breathe, so
So
therefore
there is
there is no reason for the particle to head out
out of place. So,
of
yeah,
one than another.
but you can find a very better argument than this by just considering the outside outside that angular momentum will not be conserved. So that's why.
हाँ, so यहाँ पे मतलब what I guess Noether would say is that since there is a rotational symmetry associated, uh, नहीं, so there are set of these things like if your physical laws are symmetry in time, like symmetric in time, then I guess momentum, energy, or momentum is conserved. If they are symmetric in space, momentum is conserved. Similarly, if they are symmetric in terms of rotation, your angular momentum is conserved. These are sort of set, rules, I guess. Yeah. So if you
Yeah.
no, it means that you take your system, the entire system, rotate it by arbitrary angle, and and after that the dynamics remain same. Then it is symmetry under rotation.
So, no, so I have doubt in
Yeah,
that
yeah,
term.
yeah.
Yeah. So actually, when an object is rotating, it has a plane along which most of its vectors are, means the angular velocity and other vectors are on that plane,
हम्म
on along that
अरे नहीं
side,
जो
means
जो जो
along that
एंगुलर
side.
एंगुलर हाँ जो एक साइड में हम डिसाइड करते हैं ना कि एंगुलर मोमेंटम इस साइड है या
Yeah,
एंगुलर
means
वेक्टर
according
ओमेगा
to
बार
right
एक यहाँ
hand
पे
rule,
वो राइट हैंड रूल है,
right?
इट्स अ कन्वेंशन, आप
Yeah,
उसको
it's a
रिवर्स कर
convention.
दो,
So,
कोई दिक्कत नहीं
so
है.
yeah, I understand, but still, when we have made a differentiation, so there is a side which has along which if we push the object, then it would means different means it would be a different outcome than if we push it on the other side.
सर समझ में नहीं आ रहा यार,
Means
तो आई हाँ
because the omega is on the other way, no? So the
नहीं नहीं
angle,
नहीं नहीं,
yeah,
वो
the
we
angle between
didn't choose
the,
that.
the angle between the displacement and angle between the omega will change, and it will be. I'm saying that
अरे
way.
वो नहीं, अगर अगर हाँ, so what I think you are trying to say is that अगर आप एंगल बदलते हो तो नेगेटिव नेगेटिव आके सब कैंसिल हो जाएंगे लास्ट में, एटलीस्ट
Okay,
दैट्स
okay.
माय इनसाइट आई गेस, कि वरना फिर उल्टा सीधा हो जाएगा यार. एक सर्कल बना दो, या प्लेन, या सर्कल.
Okay, I'm saying that push the particle with an angle with the plane
Or
which,
he
yeah,
is
push it.
talking about that small perturbation which comes when you push this, like slightly push it out of the plane.
Yeah, and then because it push it on the other direction, it deviates a little differently because the component of velocity comes in the other direction as compared to when we push it along the first.
हाँ तो यहाँ पे मतलब हाँ,
No, I'm not saying
नहीं
that.
नहीं नहीं
Like, if you
हाँ
displace it on in a direction and displace on other, the angles with the velocity will be same, but it will have a positive as well as negative effect. Means if you push it on the direction which is along the velocity, means the cos component there is a positive. Yeah, the sine
या
effect, so it might slow down or it might speed up, so it's not symmetric, I feel.
नहीं, इट वुड बी सिमेट्रिक. तो आपका मतलब एल बार भी शिफ्ट हो रहा है ना, द न्यू एल
uh,
बार,
yeah, L bar is
वो भी आउट
yeah
ऑफ प्लेन शिफ्ट होगा थोड़ा.
yeah,
तो
out of, yeah,
essentially
L bar is
valid.
not plane, it's perpendicular to plane, no, so it will
हाँ,
shift.
L bar is perpendicular to plane, but when you push this small velocity, नहीं,
Yeah.
एक सेकंड, आप velocity in the plane दे रहे हो, or you are giving velocity in out of plane or something like that?
No, it's in the plane, I think. No, I am giving the
So,
displacement is out of plane, but the velocity which is moving is in the plane.
uh, when disturbance,
Yeah,
yeah, along the k cap, yeah.
yeah, along the k cap. it might not be in the k cap, but it has some component along the k cap.
Some component in the k cap. Wait.
Yeah, but I'm saying that if I put a displacement like this, but if I put a same displacement means just the negative of it. Yeah, just
Okay,
the
so
negative.
he claiming that the two scenarios would be different.
I think
Uh,
because when you take the according to the displacement, if you take the what do you call, what can we say, getting the right word,
component.
yeah, means the components will be different because we take the vector, we take the vector, we don't take the directly the dot, we take the vector because the angle which it makes with the not the angle, the component. I'm not saying exactly perpendicular displacement, I'm saying about a displacement which is at some angle with the plane.
Okay. तो
So
अच्छा आप कह रहे हो अच्छा थोड़ा सा मतलब with angle so
yeah,
it
yeah,
it
so
will
here
हाँ
so here if you, so the angle with the angle with the angular momentum will be different at both the case, in both the cases.
हाँ but then आपका angular momentum
Yeah,
भी
see, like
बदल
here,
जाएगा ना the
yeah,
new
if on the in the if it is if we consider the direction of L.
yeah तो L
Okay,
बदल रहा है ना वहाँ पे the new L yeah
okay, now I get it. Yeah, L basically changes too, so it's symmetric in a
yeah
way.
तो वो symmetry consider रखेगा हमेशा
Mm. So this way we can understand why it doesn't deviates out of plane.
it's equally हाँ this side और this side तो वो बीच में ही रहेगा
It's just, I think it's the contrapositive from the statement which we were presenting.
so yeah about that मेरा एक मतलब बहुत उल्टा सीधा सा argument है ये but yeah I'll just say it so Newton's laws of mechanics are deterministic in nature आप ऐसे probabilistic outcomes नहीं ला सकते it will
Yeah,
basically
yeah,
violate the entire thing
I was saying the same because we are talking about classical mechanics and we are going into probabilities which are not usually classical.
uh, in classical so but yeah but the same given scenario in a quantum realm I don't know what will happen so it has every right to choose
Okay.
yeah it has to go there because the laws are deterministic आपने कहीं पे भी intrinsically probability deduce किया ही नहीं yeah but studying this in a quantum system would be super interesting हाँ वो खत्म हो जाएगा सब because it is then analogous to your double slit experiment with a single photon or a single electron
Yeah, but still,
there are two slits the electron chooses to go through both
the yeah. So I'm saying that then we go to quantum then from this example only.
अरे नहीं कर पाएंगे यार वो साला स्टार्ट से स्क्रैच से शुरू करना पड़ेगा
Okay, okay, yeah, it can
तो
be a good research
तो
project or
तेरी
some kind.
तो उसमें उसमें यार तुम वेलोसिटी डिफाइन कैसे करोगे फिर
Yeah, because we cannot measure
दिखाओगे
it.
कैसे पिक्टोरियली आप वेलोसिटी मेजर नहीं कर सकते
हाँ वो बात भी है.
इसको फिर एब्स्ट्रैक्टली आप इसका एक तो वेव फंक्शन पता करो वहां से कुछ हो
And,
और
and,
वेव
and
फंक्शन
then
पता करने
basically,
के लिए
but
साले
other
हाँ
thing is that we are not talking about points. We are talking point particles. We are talking about systems of yeah, we're talking about system of planets and objects. We're not talking about point particles here. So that's the thing. No.
yeah but a very good I think quantum mechanical example would be the hydrogen atom in this case because आपका एक
Mm,
nucleus है which acts
yeah,
as a
but
center point
because here we are the examples which Sir gave, he used gravitation mainly. Didn't use any electromagnetic. Yeah.
even electromagnetic is the same law like mathematically it's
Yeah,
same
but I'm telling that when we go into those small scales, there are
Mhm.
other laws. Newton's laws, they are not that good there.
हाँ
So
so like वही मैं कह रहा हूँ कि Coulomb's law holds true हाँ to a much
yeah,
higher degree like आप जब तक न्यूक्लियर लेवल पे नहीं जाएंगे तब तक Coulomb's law is pretty much holding good
okay.
so yeah a very good model which I think right now is the hydrogen because आपका एक सेंटर न्यूक्लियस है, there's a inverse r square law, the force, your basically the electromagnetic force, and the electron is revolving around the nucleus. Yeah, that's the classical picture. The quantum
classical
analogous version would be your s orbital thing. Or if you see s,
would be-
it is symmetric
it
in
would be-
3D space.
Yeah, it would not be a circle. I think.
तो सर्कल नहीं बना सकते उसमें.
It
In
would
fact, I
probably-
don't think. यार, is there any two-dimensional quantum mechanical system that you know of, Praveen?
I don't remember any names. I don't know that much.
Yeah.
Let me Google.
Through a
Yeah,
polarizer.
means you have polarized a ray of light. Not ray means. No, there. When I'm searching this, there are two states. Classical quantum two-dimensional hydrogen. Hydrogen molecules can show two-dimensional systems as per Reed College.
अच्छा, पता नहीं.
Okay. Okay. No, I'm not saying this. I'm
Hydrogen is
saying
3D symmetric, right?
no. Here it is. I don't know two-dimensional quantum theory of two-dimensional hydrogen. I don't know. I got this on Google.
Yeah,
I'm
उसके
showing.
उसमें वो show कर रहा है.
Go to my F stream. Is it visible? No, yeah. Here. It's a paper of 1999.
ओह तेरी, काफी पुराना क्वेश्चन है यार.
But I don't know. I just googled two-dimensional
Okay.
quantum system. Yeah, it showed
Mhm.
like this. I'm not.
तो hypothetical होगा ना यार ये.
पता
Like
नहीं.
वो specifically mention कर रहा है two-dimensional hydrogen.
Why examine this toy system, or is it a toy?
Good. 2D
Yeah,
space,
he has. Yeah, basically he has removed the Z components here. Yeah, you can see here.
अबे ऐसे तो साला मैं भी एक पेपर लिख दूं यार.
Huh?
ऐसे
Yeah,
तो साला एक पेपर मैं भी लिख दूं.
It's not a small paper. It's 21 pages. He cannot.
21 pages. Oh my god.
He's not written in just some layman terms. He has used some. He might have used some
एक सेकंड
thinking.
ऊपर से kinetic energy expression देख.
Yeah, here.
L square. तो ये
Okay, let me.
अच्छा ये old quantum theory यूज कर रहा होगा इसमें.
Yeah,
हाँ
yeah.
हाँ वो भी कर. अरे old quantum theory is
इसमें
whatever
velocity-
happened till Bohr, like till
velocity
Bohr
समय
atom.
velocity उस समय वो नहीं हुआ था. I
उसमें
mean,
वो Heisenberg include नहीं होता है उसमें,
include
but
नहीं हुआ था. Yeah.
हाँ,
Yeah,
but
he's
you
using that only.
हाँ, yeah. So in old quantum theory, you take energy quantization as an axiom without actually including Heisenberg principle.
Now I heard a new name. Do you know anything about this?
Without including uncertainty principle.
You you don't get it. Means basically it's Bohr. Bohr gave quantum energy quantization without giving any.
नहीं. First historically, yeah. I
It
don't
doesn't use.
know that,
It
but
doesn't use. No. I think
it
as
doesn't
far as
use
I
wave.
have heard, yeah, it doesn't use waves. It's just
Waves, हाँ.
yeah, it's atom. Means it's particle based.
It is like in हाँ.
See.
तब you
You
have
can
to
see.
include
See here.
uncertainty thing. हाँ.
Wait a minute. See here. What makes this result so remarkable that the new quantum theory would proceed from one to Schrodinger equation, and one is this equation. The one is where is one?
There is one. ढूंढो यार.
This is the one. This is
There you go.
H.
Yeah. It makes as an
So
axiom,
here
yes.
they started with the old quantum theory, and then they went to
Move to the new quantum
they
theory.
moved to the new here, and then they developed this equation which I'm not.
प्रवीण, आपके पीएसओ में ओल्ड पढ़ाया था?
Praveen is Y21.
अच्छा प्रवीण आप भी Y21 है?
What did you think?
अरे मैं I thought you are Y19. Oh.
Only.
अच्छा you are
We are waiting for
प्रवीण is
Y19s to come.
Y21 और मानस पांडे भी साला Y21 है.
Y21. Yeah.
साले अच्छा आर्गुमेंट दे रहे यार तुम लोग, मतलब मजा आ गया.
नहीं पढ़ने में इंटरेस्ट है तो फिजिक्स तो मैं फाइनमैन थोड़ा पढ़ा हूँ तो मुझे फाइनमैन से बहुत आइडिया है क्वांटम सबका.
बढ़िया.
फर्स्ट एडिशन
अरे
तक
हाँ
भी खत्म ही कर लिया।
मैं जब साला
हम्म।
फर्स्ट सेम में था इतना डरता था अभी बात करने से।
वो
हाँ हाँ ओ
actually, yeah, this thing, I was very, I could say, I had a very beneficial thing because the person who taught me physics in class 11th and 12th, not the coaching in my school, he was
ओके
kind of very enthusiastic. Means there's a
अच्छा
boy, yeah, he has went to, he is presently the fellow of the, what do you call, Royal Society. No, no, Royal Society, Royal
ओ
Society. And he's
लंदन
my 1 year senior, yeah, London.
ओ तेरी
He
ओ
wrote a
तेरी
paper in class 11th on
अच्छा
black hole. Okay, let me show
अरे
you.
दिया नहीं
Yeah,
जूनियर
this
जूनियर
is,
फेल होगा यार
yeah, he is the
है
person.
बच्चों का है कुछ
No, 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 he's not the junior fellow. He's the true
अच्छा
fellow,
अमल
FRS.
पुष्प
Yeah,
ओ एफआरएस ओ भाई
yeah, he's,
खोल
I know
इसका
him
लिंक्डइन
very.
खोल एक बार
Okay, no, no,
नहीं नहीं
he's
नहीं
from my school. I'm telling you. Let me see. See, he's from my school, Delhi Public School, Patna. I'm from this school,
अच्छा
and
ओके
my teacher and my physics teacher and his physics teacher were same.
सेम ओके
And what he did, let me tell you what he did in 2019, I think.
हाँ
See,
हाँ
no, this is not his publication. He wrote a publication, yeah, this one, possible new effects on black hole, and he has mentioned my teacher to here, so you can see how wonderful my teacher has been so wonderful. So that's why I have a lot.
एक सेकंड साला 11th में ब्लैक होल्स तक कैसे चला गया
He was a big fan of Stephen Hawking, so he dived into his books a lot.
तो आप स्टीफन हॉकिंग से ब्लैक होल्स
But
तक नहीं जा सकते सवाल ही नहीं उठता
I don't know.
पॉपुलर
No, no,
साइंस है
no.
यार वो
I don't know exactly his story, but I
एक सेकंड यार ये पेपर कहाँ पे पब्लिश हुआ है ये बता
research gate. मैं वही तो मैं look at wait a minute, मैं उसका पेपर ढूंढता हूँ.
पेपर ढूंढ
अरे उसको फिर वो सर मार्टिन
रिसर्च
रीस से वो सर मार्टिन रीस से वो किया था, आई मीन पब्लिकेशन. या यू कैन
सवाल ही
सी,
नहीं उठता यार
मैं दिखा दो,
खोल
फोटो है उसका, गजब बात कर, फोटो.
फोटो फोटो
वो
सुन
इट
सुन
वाज
सुन
नॉट
सुन
हिज एडवाइस, इसका फोटो भी मैं दिखाता हूँ मैं. अरे मैं जानता हूँ इस
अरे
बंदे को, अब
बात
मुझे.
बात क्या होगा बे
अरे हाँ,
अरे
बात भी
जानते
किया
मैं
था.
but अरे क्रेडिबिलिटी क्वेश्चन नहीं कर रहा
हाँ मैं
मैं
जानता हूँ, आई
कह
मीन.
रहा हूँ कि एक बार उसका वो आर्टिकल दिखाना खोल के
हाँ वही दिखा रहा हूँ, ये आर्टिकल उसका पॉसिबल, ये फर्स्ट आर्टिकल था 2018 में दिया था, देखिए.
अच्छा प्री प्रिंट है फुल टेक्स्ट
2018
अवेलेबल पे
मतलब
क्लिक
जब वो क्लास
रीड
7th में था मैं.
रीड फाइल पे जा
हाँ जा रहा हूँ, रोड साइड रीड फॉर यू,
नीचे हाँ वहीं पे दबाओ नॉट
पीडीएफ.
अवेलेबल सारा ये हब ओपन कर देगा
कहाँ है, आई
बट
मीन
यार
वेयर
आई
इज इट.
जस्ट वांटेड टू सी हाँ इसका वो खोल यार
मैं पीडीएफ डाउनलोड
डी
करता हूँ.
डी पे दबा दे वो दे देगा तुम्हें ऑफिशियल उस पे ले जाएगा ऊपर ऊपर डीओआई मई 2018 के नीचे वाला हाँ
ये ना, हाँ
दबाओ
वही
उसको।
बात.
नहीं नहीं
ये
खुल रहा है खुल रहा है खुल रहा
अपने आप खोल देगा, वही खोल रहा है.
है ये साला ये खोल रहा है ब्रो कॉपी डीओआई देन
वेट अ मिनट. I cannot copy it. Okay, I need to sign in first. Without login, I cannot do it.
अरे मत करना कॉपी कर यार
नहीं कर सकते कॉपी ना. I cannot copy. जैसे मैं कॉपी क्लिक करा तो मुझे वो
अबे
बोल रहा है
रुक
sign
मैं
करने के लिए.
खोलता हूँ अपने 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 लैपटॉप में खोलते हैं
कॉपी
यार
कॉपी करती कहाँ डालना है, डीओआई कहाँ डालना है, I mean.
साई हब में डाल दे अरे ऐसे तो सैयक भट्टाचार्य का नाम सुना है
नहीं, ये बंदे को मैं पर्सनली जानता हूँ, I know this man personally, so.
अरे मैं क्रेडिबिलिटी तो इंडा क्वेश्चन कर रहा हूँ
हम, और इसका बहुत, मैं इस पेपर पढ़ा था, इसने मेरे सर को भी उसमें, I mean, वो किया, तो मैं इसका अंदर फिजिक्स से बहुत इंटरेस्ट था.
अच्छा
नहीं यार, इट्स नॉट हियर. मैं साइन इन कर दूँ, साइन इन अकाउंट में कर दूँ.
नाम क्या है बंदे का अमल
अमल पुष्प.
पुष्प
अरे कुछ भी डाल क्या भाई. He no, actually the weirdest thing you would find that he has not gone to a good college. He's doing he's doing his bachelor's from Manipal Institute of Technology. But see his what you call, he's a fellow of Royal Astronomical Society. He's a president of some Olympia team, but he didn't get a good college. See, Manipal University.
अरे
I
नहीं वो
वो इससे
देखते हैं
like let me tell you a great thing about means you would be means it's a very different thing to find because this person had failed in class 12th in physics. Wait a minute, let me
नहीं
yeah
नहीं नहीं the writing paper and the other things
okay,
are
let me
way different things like yeah. आजा
wait
भाई
a minute. Nico, let me show you
आजा
I
बैठो
miss connection no.
अबे ये
Yeah, this is
चल
or
एंड्रॉइड
maybe
फिजिक्स को कोट कर रहा है यार
yeah this is
अमल पुष्प
yeah this is he's my senior he's my connection here. So let me tell you let me give his paper from here I could say publication yeah here
अरे आजा भाई
Amal
अभी
Push
ही
yeah
इस बेचारे सेट कर
I
रहा
know
है
him
सब
pretty well means I have messaged him multiple times so I know him very pretty well.
अरे इसमें यार जर्नल का नाम नहीं दे रहा
No, he's
अरे
from
आर्कवे
Patna.
में पब्लिश किया होगा
No, he's from
हाँ मणिपाल वो
from
अरे
Jaipur.
मणिपाल यूनिवर्सिटी प्राइवेट है यार वो हर जगह ब्रांच है उसके
Yeah,
नो नो
so
नो 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 मणिपाल आई गेस इज द मेन ब्रांच और समथिंग अबे ये वो नहीं है यार प्री प्रिंट है ये अर्ली स्टेज रिसर्च
I'm just showing you that. Yeah, he means I it's weird. तुम में से so yeah, means Roger Campos. Yeah, I kind of know him too in a way. Means I don't know him. I know a person who knows him. Yeah, let me show. Okay, I can prove you now. See, let me show you his. Actually, I'm quite good in making connections. This is the person. This person, Arnav Ramakrishnan. Yeah, he. Hello.
हाँ हाँ हाँ
Yeah,
बताओ
he is also from. He has. I cannot. I know this guy, and he. What? I've met. No, I studied in the. Yeah, this is the person. See, I can prove you. See, so you can see this photo.
हाँ रॉजर पेनरोज के
I
साथ
no. He works under his PhD student. Roger Perot was advisor of this person's PhD advisor. So he's the advisor of his advisor. So yeah. So this is also one of my I know this he's also one of my alumni. Yeah, he's doing physics. He's doing physics. Yeah, he's doing. I'm telling you. No, that person is doing cosmology. The other one who's the FRAS.
अरे ये को क्यूएफटी वगैरह के लिए करता होगा
ये तो हाइड्रोजन एनर्जी रिसर्च कॉन्स्ट वहाँ पे कर रहा है ये तो अलग ये अलग चीज है
ये अलग है
मैं so basically the person who I studied the person from whom I studied
Hmm.
he was a student means he had these kinds of students and he himself is a student of HC Verma
ओहो
so so that's why I know a lot of physics and from him only so
बढ़िया है
physics में से interest हुआ
चलो यार थोड़ा लेट हो गया मैं निकलता
हाँ चलो कि मेरा भी वहाँ पे शायद मेरी
हूँ और मतलब पूछना हो तो
नहीं आई हैव टू गो मेरे ब्रांच वाले सब मूवी स्ट्रीम कर रहे हैं आज ओके बाय
चलो चलो अरे कौन से ब्रांच के यार both are from physics okay and from what area are you from like so you're from Bangalore and Manas is from Jaipur I guess Patna he told Patna he told Patna yeah Bangalore बढ़िया यार निशान को जानता है इस वाई अरे वो लिया था ना अरे वो मीट लिया था ना पे DUGC nominee आप अच्छा you didn't no he took the other one in which there were you didn't join anything okay cool चिल्ला चिल्ला I am a Y20 in physics, man. Physics. Uh, yeah, nice talking to you. और भाई पढ़ लेना, एक sincere suggestion है साला. CPI वगैरह look maintain it above 8.5. At least like third semester. Uh, like at least by end of your third sem, it should be above 8.5 at all costs. By hook or by crook कर ले. Because मेरी नहीं है and I know what problems I'm facing right now. Okay, तो तुम थोड़ा अच्छे से करना. चल है. और कुछ पूछना है? या हाँ. ESC 101 is what do I say? In online mode, it's a fucked up course. Okay, literally it's a fucked up course because prof जो है वो YouTube का playlist share करता है. उसमें सारे 5-10 मिनट की वीडियोस रहते हैं, वही देख के सीखना होता है. So my suggestion is तुम ट्राई कर अपने आप से प्रैक्टिस करने का, because like more than half of the course is related to what is known as competitive programming. Okay, he gives you a problem, you need to find the logic, and you need to the best logic and algorithm to solve it, and you need to code it in C language. Okay, that's what would be happening in your assignment labs and your quizzes. तो फिर भी technical होते हैं थोड़ा बहुत, हाँ, but labs mainly ये होता है उसमें. So the trick is that practice. Programming is just like doing your math. मतलब बचपन में हम लोग arithmetic सीखते थे. We learned how to add numbers. There, yeah. So so I don't know what they taught in your school, because I didn't do it in my school. uh, तो अगर तुम्हें लॉजिक लिख के कोड करना आता है in whatever language, the course would be very easy. If you don't know that, then you'll have a tough time with the course. But the upshot is that सबके लिए hard है. So with sincere efforts, I guess it should be pretty easy. For me, it is engineering drawing, man. I cannot draw. हाँ तो चिल है यार तुम्हारा फिर. I know that thing. So for that, my sincere suggestion is go through the examples, not in notes, but take some textbook of real analysis. I personally like W. Rudin. Rudin करके हाँ एक बुक है, उसमें एग्जाम्पल्स अच्छे अच्छे हैं, तो आप वो देख लो. And try to solve the assignment and problem sets तो कर लेना, but yeah, assignments are compulsory sort of, कर लेना. So while doing assignment, you do not solve it like JE. Rather, you try to, write the formal logic and the formal proof of it. And don't worry, after mid-sem, it will be like JE only. वो सिर्फ mid-sem तक ही वो रहता है उसमें proof वगैरह का. हाँ, mid-sem के बाद साला फॉर्मूला याद कर, डाल, खत्म कर बात. अरे how did that happen? That happens, man. And if you are interested in or doing maths courses in your future, then yeah, you should learn that at least. या और तो बाकी सब चिल होगा. It's a mix of both. It's basically linear algebra is for 60%, I guess. The 40% is ODEs, ordinary differential equations. It's not has proof, but this linear algebra has a lot of proofs. अब बेसिकली प्रूफ नहीं भी है तब भी क्वेश्चन दे रहा है तब भी आपको उसी तरीके से लिखना होगा, starting with something and then step by step proving things out, or step by step deriving things out. And basically that's how mathematics works. Even in if you go to mathematics literature वो होगा. अरे, मोहंती है, प्रसार मोहंती. अजय ठाकुर and second half नंदिनी नीलकंठन. अच्छा पता नहीं यार, हमको दूसरे थे तो. अरे तुम्हें अच्छा चाहिए तो there's this NPTEL में जा. NPTEL में I'll tell his name just a sec. IIT कानपुर का है एक बंदा. या हाँ 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 हाँ. वो अच्छा पढ़ाते थे. Okay, that playlist is awesome. Like yeah, you do that. चिल है. चिल कैंपस आ जाओ साथ में करते हैं. अरे आजा आजा भाई. तुम लोगों का ओरिएंटेशन होगा, हम लोग नाचेंगे उसमें. आ, चल. या बाय.
आओ हम गाएं, हाथ पकड़ के हम उड़ते जाएं, प्यार की खुशी हम बांटेंगे, सबसे आगे हमारा दोस्त है डोरेमोन.
अरे नहीं, वो तो नाराज हो गया. उसे वापस लाने के लिए मुझे कुछ करना होगा. डोरेमोन, बहुत ठंड है. पता नहीं ये जगह साउथ पोल है या नॉर्थ पोल. डोरेमोन, कहाँ हो तुम? जल्दी सामने आओ, नहीं तो तुम्हारी कुल्फी जम जाएगी. तुम्हारे चक्कर में मैं बीमार पड़ जाऊंगा. डोरेमोन. हाँ, अच्छा तो तुम वहाँ छिपे हुए हो. डोरेमोन. मिल गए. हाँ? हाँ? ये क्या है? ये क्या? देखता हूँ. हाँ, ये तो कोई मशीन लगती है. लेकिन ये मशीन आसमान में क्या कर रही थी? बचाओ मुझे! कोई तो बचाओ! बचाओ मुझे डोरेमोन! नोबिता, ये क्या हो रहा है? मॉम, मैं गिर गया था. हाँ, पता नहीं ये क्या है. हाँ? ये तो वही चीज है. पर ये है क्या?